In the last session, we have explored a formal model of evaluation of expressions, which is called the substitution model. And we have seen that there's more than one way to evaluate an expression. We've identified the call by name and call by value evaluation strategies. And in this session, we're going to compare them a little bit further, in particular in what regards termination. So if we look at call by name and call by value and how they relate to termination, then we know that both evaluation strategies will always reduce the same value, provided evaluations terminate. But what if evaluations do not terminate? We have seen in the last session that some of the expressions actually do not give a value in a finite number of steps. So there we have an important theorem which says that if the call by value evaluation of an expression terminates, then the call by name evaluation of that same expression will terminate also. And furthermore, the other direction is not true. So call by name termination does not imply call by value termination. So let's see an example. Can we find an expression that terminates under call by name but not under call by value? Okay, so let's see how we would go about that. We define a function first that takes simply two parameters, x and y, and returns the first one x, so it forgets about y. And then we consider the expression first of 1 and loop, so we pass a non-terminating computation into the second parameter. Under call by name, what will happen? Well, call by name will reduce the first expression without reducing the arguments, so it would just yield 1 in a single step, the first argument, and the evaluation would stop in a value, obviously. Under call by value, we have to reduce the arguments to this expression, so we have to reduce loop, and well, we know that loop reduces to itself, so we would reduce the arguments infinitely often. The whole expression would always reduce to itself, and we would make no progress. So that's another example of an infinite loop. In Scala, we normally use call by value. You might ask, well, given the advantages of call by name, that it terminates more often, why call by value? Well, it turns out that for expressions in practice, call by value is often exponentially more efficient than call by name, because it avoids this repeated recomputation of argument expressions that call by name entails. The other argument for call by value is that it plays much nicer with imperative effects and side effects, because you tend to know much better when expressions will be evaluated. Since Scala has also an imperative side, call by value is the standard choice. Except that sometimes you really want to force call by name, and Scala lets you do that also. You do that by adding an arrow in front of the parameter type. So this function const1 takes an x parameter int and a y parameter of type arrow int, and that means that the parameter y is also an int, but it will be passed call by name. So to demonstrate the difference between the two parameters, let's trace the evaluations of two expressions, const1 1 plus 2 loop, and const1 of loop and 1 plus 2. So the first one, const1 1 plus 2 loop, is, well, the first parameter is called by value, so we have to reduce that to 3, so that will be 3, and the rest will be kept as it was before. The second parameter we do not need to reduce because it's a call by name parameter, so we are done with the argument lists. We can apply the function, and the function would just always reduce to 1, so it would in fact ignore both of its parameters. That's the first expression. The second expression here, we would have const1 of loop and 1 plus 2. Well, here we have to reduce the first argument because it's called by value, and we get into the same situation that loop reduces to itself, so no progress, and we get another infinite cycle.